At 7:47 a.m. Eastern Time, on October 29, 2025, something extraordinary happened. The interstellar object Atlas reached its perihelion, the closest point to our star in its entire trajectory. According to the JPL Horizon system, this moment was predicted with a precision of just minutes, marking one of the most anticipated checkpoints in modern astronomy. On the very same morning, Harvard astrophysicist Avi Loeb published new images of Atlas on his page, underscoring the scientific weight of the day. But almost immediately, a problem emerged. A problem so fundamental that it reshaped the entire narrative. At the exact moment Atlas brushed past the sun at its closest approach, the object became completely invisible to every telescope on Earth. Not because we lacked technology, not because we lacked preparation, but because Atlas slipped behind the sun itself, hidden by the overwhelming brilliance of our star. In his Medium blog, Avi Loeb described it as a mystery at the moment of greatest importance. And he's right. For a brief window of time, the universe staged a cosmic blackout. At the instant when Atlas was being bombarded with intense solar heating, precisely when a fragile comet should show dramatic activity, we lost our only view. What happened at Perihelion? Did Atlas fragment into a debris cloud? Did it flare, brighten, darken, change course? Right now, we simply don't know. And that uncertainty is what ignites the tension, the sense that something crucial occurred, hidden in the blinding shadow of our own star. While Atlas slipped behind the sun, something else was happening, something we were painfully aware of, yet powerless to change. At that exact moment, the object was being blasted with 770 watts of solar energy per square meter, an intense thermal load capable of tearing apart a weakly bound comet. If Atlas were a typical icy body, this extreme heating should have triggered violent outgassing, fragmentation, or even a full disintegration cascade. And yet, as all of this may have been unfolding, we had no direct way to see it. Avi Loeb highlighted another striking detail. If Earth had been positioned just 6 months earlier, or 6 months later in its orbit, the story would be radically different. Instead of losing sight of Atlas behind the sun, we would have been perfectly placed to illuminate it with planetary radar. In that alternate scenario, a simple orbital shift, Atlas would have passed only 54 million kilometers from Earth. That distance sits comfortably within the reach of existing radar systems, giving us the ability to map its surface, measure its precise size, and even build 3D reconstructions of the object as it rotated every 16.2 hours. But that isn't the reality we have. On December 19, 2025, even at the closest approach we will get, Atlas will still be 269 million kilometers away, far beyond radar capability. No direct imaging, no surface data, no structural mapping. It's a cosmic irony. Just when Atlas might be revealing its true nature, the universe positioned us in the one place where we couldn't observe it. Before we dive deeper into the anomalies, it's important to understand what Atlas actually is. Because unlike the two interstellar visitors before it, Oumuamua in 2017 and Borisov in 2019, Atlas is in a completely different category. Atlas is enormous. Based on its brightness and minimal size estimates, the object spans at least 5 kilometers across. That makes it 1 million times more massive than Oumuamua and more than 1,000 times larger than 2I, Borisov. In other words, Atlas is not a pebble drifting through the void. It is a mountain-sized intruder, moving through our solar system with silent, deliberate momentum. To put the scale into perspective, SpaceX's Starship, currently the largest active rocket humanity has ever built, is about 100 times smaller. Even our most ambitious engineering projects look microscopic compared to this interstellar giant. And yet, despite its colossal size, Atlas behaves nothing like any large comet or asteroid we've ever recorded. The bigger an interstellar object is, the more predictable its behavior should be. Gravity dominates, physics stabilizes, chaos decreases. But Atlas breaks that rule. The largest interstellar object ever detected has turned out to be the most unpredictable, the most anomalous, and the most statistically impossible of them all. And that leads us directly into the heart of the mystery, the 8 impossible anomalies. For the past several months, Atlas has refused to behave like anything we recognize. The deeper scientists look, the stranger it becomes. and Avi Loeb has now classified it with a score of 4 on the Loeb scale, a ranking system ranging from 0 certainly natural to 1-0 certainly technological. A score of 4 may sound modest, but the reasoning behind it is anything but. Loeb points to 8 anomalies, each statistically improbable on its own. But taken together, they form a pattern so unlikely that it defies coincidence. Let's break them down. 1. A perfectly aligned trajectory probability, 0.2%. Interstellar objects come from random directions in the galaxy. They do not know where our planets orbit. Yet, Atlas entered the solar system aligned within just 5 degrees of the ecliptic plane, the thin disk where all major planets circle the Sunday. This narrow alignment is extraordinary. Natural interstellar debris should arrive at arbitrary inclinations, not gliding almost perfectly along our planetary highway. It's as if the object approached on a path specifically optimized for a solar system tour. 2. The anti-tail, a jet pointing toward the sun. During July and August 2025, astronomers detected something that should not exist, an anti-tail. Instead of ejecting dust away from the sun, a fundamental behavior caused by radiation pressure, Atlas released a jet directly toward the Sunday. No natural comet does this. Not Oumuamua, not Borisov. Not any comet ever recorded. A jet aimed inward suggests a mechanism overriding natural physics, either highly unusual internal dynamics or something more deliberate. 3. Massive, yet fast probability, is less than 0.1%. Atlas isn't just large, it's moving faster than similar objects of its mass should. In astrophysics, large bodies tend to carry the gravitational memory of their formation regions, making them slower and dynamically colder. But Atlas is both massive and fast, an unlikely combination. This pairing violates expectations of standard comet formation. It hints at either a very unusual origin environment or potential propulsion. 4. Perfect timing near planets. Probability, 0.005%. The object's path takes it near Mars, Venus, and Jupiter in an uncanny sequence. All 3 encounters fall within tight, improbable windows. And the most extraordinary timing of all? Atlas becomes completely hidden from Earth at Perihelion, during the single most scientifically important moment of its entire solar pass. The odds of this sequence arising naturally are incredibly small. The effect feels almost intentional, maximizing proximity to planets while minimizing detectability from Earth. 5. Industrial-like metal composition nickel is greater than iron spectral data of Atlas's gaseous plume reveals a shocking ratio, more nickel than iron. In natural cosmic environments, iron is vastly more common. Nickel-rich mixtures appear only in specialized, high-temperature industrial alloys produced by technological civilizations including ours. Even more puzzling, the nickel-to-cyanide ratio in Atlas's tail is orders of magnitude higher than anything seen in known comets. This isn't the signature of a dirty snowball. It resembles processed or refined material. 6. Almost no water, only 4% by mass. Typical comets consist of 80–90% water ice. That is why they brighten near the Sunday. But Atlas contains just 4% water, making it radically different from conventional cometary bodies. Without water, the entire definition of a comet breaks down. A dry, metallic object with minimal ice fits better with an asteroid or a constructed structure. 7. Extreme negative polarization. Unprecedented polarization measurements reveal how light scatters off a surface. Every comet ever observed has produced characteristic polarization signatures until now. Atlas shows extreme negative polarization, a value never recorded for any natural comet, including Borisov. This suggests a surface texture or composition unlike anything known, possibly smooth, reflective, structured, or engineered. 8. Arrival from the direction of the wow. Signal probability, 0.6%. One of astronomy's great mysteries occurred in 1977, the famous wow signal. A strong, unexplained radio burst, believed by some to be artificial. The directional uncertainty of that signal covers a narrow region of sky. Atlas entered from a direction within 9 degrees of that region. This correlation does not prove anything, but statistically, it is significant enough to raise eyebrows. Two of the greatest anomalies in modern astronomy may share an origin point: the probability problem. When you multiply the statistical odds of all 8 anomalies occurring naturally, the result is astonishing. Less than 1 inch 10 quadrillion. A number so small it approaches impossibility. Individually, each anomaly is strange. Together, they challenge the entire assumption that Atlas is a natural object. If any one of these signals turns out to be technological, from propulsion to material composition, then Atlas isn't just another visitor. It's a message in motion, and the universe may be trying to tell us something. With so many anomalies converging at once, the scientific community has entered a state of heightened vigilance. Radio observatories around the world are now tracking Atlas continuously, watching for any sign, even the faintest whisper, that might reveal its true nature. Congresswoman Anna Paulina Luna is actively working to release the high-resolution high-rise images from October 2nd, a dataset many believe could contain crucial clues about Atlas's structure and behavior. Scientists know exactly what to look for. If Atlas performs maneuvers, releases mini-probes, emits radio transmissions, shows artificial illumination, or radiates excess heat beyond natural outgassing, then the conclusion becomes unavoidable. It is technological. But the natural scenario remains on the table. If Atlas is truly a comet, then the extreme heating at Perihelion may have fragmented it, producing a brilliant burst of gas and dust, a cosmic firework we were unable to witness. And now, all eyes turn to what happens next. Avi Loeb has emphasized one point with unusual clarity. We must treat the technological hypothesis seriously. Not because we want Atlas to be artificial, but because ignoring that possibility would be intellectually irresponsible. If even one of the 8 anomalies originates from engineering, then Atlas represents capabilities far beyond anything humanity has ever achieved: propulsion that defies known cometary physics, materials forged under conditions we cannot reproduce, navigation accuracy that borders on deliberate intent. The implications would be monumental. It would mean that our solar system is not isolated. It would mean that another civilization, at some point, somewhere, mastered technologies advanced enough to send objects between the stars. But even if Atlas turns out to be natural, its behavior is rewriting what we thought we knew about interstellar visitors. Either outcome changes something fundamental. In watching Atlas, we are not just studying an object. Passing through the solar system, we are witnessing a moment that may redefine humanity's place in the universe.